This is Feb-March 2024, variant 42. Question 6. So feel free to import this question onto your tablet or print this out and follow along. Part A is asking us to calculate the length AC. The first thing that you should ask yourself when a question like this comes on your exam paper is if we can use a sine rule or can we use a cosine rule, right? And as you can clearly see, the sine rule is applicable. We have two angles, we have two sides. So the sine rule is applicable in this question. Quickly write down the formula, plug stuff into the formula, do some substitutions. We want to solve for AC, so we multiply by sine 54 on both sides. And then we simply chuck this into the calculator. The calculator gives us an answer, and we have to write the answer down to 4 decimal places. That is the first thing you need to do. This is very important, and I'll point it out later on. Not more than 4, not under 4. I would recommend 4. If you could go for 5, but that's too much work. 3 won't do the trick. Remember, you want to save time, so just go with 4 decimal places. And we want to quote the answer, obviously, so we will round this to 3 significant figures, and the answer is 15.0 centimeters. Very simple. Let's go to part B. The part B is asking us to calculate side AM. We want to calculate the length of side AM. It has given us some additional information, but to be honest, don't read that. Again, it will waste your time. Everything is in the diagram. In order for us to calculate the side AM, we need to ask ourselves, can we use the sine rule or can we use the cosine rule? Most of the time, if we have already used the sine rule in part 1, part 2 is going to test our cosine rule knowledge. And obviously, we have two sides and one angle, so we will be using the cosine rule. We have length AC. We calculated AC in the previous question. So we simply write down the cosine rule. We plug everything into the formula. Note that when I plug AC into the equation, I used the 4 decimal form, not the 3 significant figure form. And this is why we quoted it to 4 decimal places, because we want the answer that we're using in the equation to be of the highest precision, so that in the end, when we round the answer to 3 significant figures, we get the correct answer. But there is a chance that if you use 3 decimal places or 2 decimal places, in the end, you would not get the correct answer. It will be off by zero point 0.1 decimal places, and you will lose a free mark for no reason at all. So once you've substituted everything in, we want to solve for AM. So square root both sides, plug it into the calculator, quote it to 4 decimal places again, and then to present the answer to the examiner, we are going to round this off to 3 significant figures, and the answer is 15.7 centimeters. Lastly, the question the examiner is asking us to calculate the shortest distance from A to BC. Whenever this kind of question comes, the first thing that you should do is calculate the perpendicular height. Like, this is an obvious, very repeated question. Whenever it asks you to calculate the shortest distance, you always calculate the perpendicular height. It is understood. And again, perpendicular height, 90 degrees, triangles, that is, without even thinking, you should go back to your SOHCAHTOA, your trigonometry, and we will be using sine, obviously, because we have the length AC, which is our hypotenuse. We have, no, we don't really have, we have to calculate the perpendicular height, so this would be the opposite. And we will use sine, we have the angle theta. So quickly write down the formula, plug everything in, and again we are using 15.070079, which is our 4 decimal place answer, so that we can get our end answer to the highest accuracy and score the third mark. Make the perpendicular height the subject of the formula, plug everything into the calculator, round it to 3 significant figures, and our answer is 13.9.